In the last section, we talked about the ellipse. We talked about how it has two vertices, it has two foci, it's got a center, it had a major and minor axis, and we were able to answer all kinds of questions about that. It helped to draw a picture first, get your center, and measure your A, B, and C, and get all the pieces that you need. The last conic section we want to talk about is called the hyperbola. Please do not call it hyperbola. Ugh. So, we've actually worked with hyperbolas before, but we didn't really call them that. If you recall back in the day, when we had rational equations, your basic one, let's say 1 over x, the reciprocal function, he looks like this. That is actually a hyperbola. And so here's the thing. Hyperbola is going to be made up of two pieces, like you see over here in this picture, and you will have the two asymptotes. The way we typically see them is that they will be going out to the sides like this, opening up to the left and right, or they're going to be opening up, it's kind of hard to show this, opening up and down. So something kind of like this. So if I were to draw some asymptotes, it will look something like this. This is your hyperbola. You're going to have your two vertices, so vertex 1, vertex 2. You're going to have your center here in the middle, naturally. And then remember what we said about the foci. Foci are always going to be inside the curve. So you're going to have foci here and here. If you recall with an ellipse, the ellipse was the collection of all points whose sum of distances from the two foci was always going to be the same. The hyperbola is very similar, except it's the difference of the distances between the 2 points is always, between the two foci will always be the same. So the difference between this guy and this other focus, the difference there is going to be the same. Just like if I were at this point, the difference between this focus and this one, the difference between those two distances will be the same. All right. Now, when we had an ellipse, we talked about the major axis, the minor axis. Here we don't have that. Instead, what we have is that we have what's called the transverse axis. So the transverse axis is the one that goes to the center and the two foci. So this is going to be the transverse. Whoops. This is going to be the transverse axis. And then the one that is perpendicular to that and goes to this center is called the conjugate axis. All right, so get the terminology down so that when we talk about this, it makes sense. Foci are still foci, center is still the center, vertices are still vertices. Now, I told you before that you can either have them opening up out to the sides, like this, or like this, right? So how do we know which is which? Well, for an ellipse, you had just one equation that we worked with. For hyperbolas, we have two, and they're basically the same thing. It's just that one fraction is positive and the other one is negative. So here are the two forms that you're going to see. So x minus h quantity squared over a squared minus y minus k squared over b squared equals 1. And the other form that we have is y minus k squared over b squared minus x minus h squared over a squared equals 1. So when you have these forms, you need to identify which fraction is positive and which one's negative, right? So if you have the x being the positive one, then your hyperbolas are going to open up out to the left and to the right. As I would say, in my mind, it's towards the x direction, horizontally. Compared to having the y being the positive one, in which case you'll have your hyperbola opening up and down. Now, it is made up of both of these pieces, and each piece is called a branch. So these are the two branches of your hyperbola. Now, for both of these forms, c squared is going to equal a squared plus b squared. So that's a pretty easy thing to remember. And for both of these forms, the center is going to be the ordered pair HK. I'm sure that does not surprise any of you. Your asymptotes. So we come back up here to the picture. We talked about the asymptotes before. The asymptotes will be the same for both of these. Doesn't matter which one's positive or negative. So your asymptotes will be given by the equation y minus k equals plus or minus b over a times x minus h. It sounds like a lot, but it's really based off of the point-slope formula for writing equations of lines that we saw a long time ago. And this y minus k and x minus h, really just kind of pull them from these forms right here. And the reason we're using these is because we are basing this off of the center. We know that the center is going to be a point for all of these asymptotes. Every asymptote is going to go through the center. So that's the point that we focus on. And we've got the plus or minus b over a, and keeping in mind where b and a come from. B comes from the y, from the denominator of the y stuff, and a comes from the denominator of x. So that's going to connect to your rise over run. So with ellipses, we talked about how we stretch in the x and the y direction. Something kind of similar happens with hyperbolas, but what we're doing is we're going to create a rectangular box that's stretched in those directions, and as you draw the diagonals, that will inform you about what your asymptotes are. All right. Now, because of the orientation of things, this is where the similarities kind of end between these two. When you open out to the left and to the right, your transverse axis is going to be the equation y equals k, because it's going to be this horizontal line that goes through the two foci. However, for the other one, the transverse axis is going to be x is equal to h, because that's going to be the transverse axis going through the two foci. Your conjugate axis, so conjugate axis here is going to be the one that's vertical. It's going to be perpendicular to the transverse axis. And for the ones that opening out in the x direction, you have the vertical line, and that's going to be x is equal to h. And then for the conjugate axis for the vertically opening ones, that's going to be y equals k. Well, what about the vertices? What about the foci? Okay, so your vertices, as you can see here for the ones that open out in the x direction, your vertices are going to have the same y coordinate as your center, but it's going to be shifted from your center left and right by a certain amount. And that's going to be the a value right here. So your vertices are going to be h plus or minus a, comma k. And then for the vertically minded ones, your vertices will be will be h, and then k plus or minus b. And what I'm doing here is I'm letting b always be the value that's underneath the y. Okay, that way we don't have to learn a bunch of different things. And your foci, what's this? Okay. Your foci will be very similar to this, but it's going to be h plus or minus c, comma k. And then over here, it's going to be h, comma, k plus or minus c. So for this horizontal one, from here to here will be a distance of a. But then as you go to your focus, that's going to be a distance of c. So c is always going to be larger because it's made up of a squared plus b squared. All right, so these are the basic forms that we have. And let's take a quick look at an example so we can see how all of this fits. So starting with x squared over 49 minus y squared over 9 equals 1. Now we know from this that we do have a hyperbola. The reason we know this is because you have these two fractions like we keep seeing, but one is positive and one is negative. Now, since the x1 is positive, that means that we are opening in the x direction, so it's going to look something kind of like this. Well, let's work on the accuracy of this. So as I look underneath the x, I can see that here a is going to be 7, and from here b equals 3. And while we're here, let's go ahead and talk about what the c value is. All right, so c squared is supposed to be the sum of these guys. So that's going to be 49 plus 9, and we get 58. So that means that c equals the square root of 58. Okay, we've got that stuff off to the side. Now let's answer all the questions that we can about this particular equation. Starting with the center. Well, the center is just going to be the origin, 0, 0. You don't have anything inside the x squared or inside the y squared. Your foci. Well, your foci are going to be along the x-axis because of the way that we're opening out. And it's going to be this 0 plus or minus the square root of 58. So it's going to be plus or minus the square root of 58, comma, 0. And my vertices. We're stretched out 7 units on either side of the center. So one vertex is at negative 7, 0, and the other one is at positive 7, 0. Your asymptotes. All right, so your asymptotes will be, well, we would say y minus k, but k is 0, so we're just going to say y equals plus or minus. The form says b over a. So b is 3, a is 7, and then times x. Now we could put this in parentheses, but it would be x minus 0, so that's kind of unnecessary. So these are the two asymptotes that we have. All right, so before we talk about what the domain and range are, we're going to need to draw a picture first. I think that's going to be very helpful to us. I mean, I guess you don't have to, but it is nice. But forget about this. What is the transverse axis? Well, that's going to be the one that goes through the two foci, so it's going to be horizontal, and it's y equals 0. It's going to be the same 0 that you see here for the center. And then for your conjugate axis, it's going to be x equals 0. It's going to be that vertical line that goes to the center. All right, so if I want to draw just a quick picture of this, there's my center. I'm going 1, 2, 3, 4, 5, 6, 7 to the right, 7 to the left. And that's where I'm going to have my vertices. Now, this next part's kind of tricky, or it can be. So underneath the y, you see 9, which means b is 3. So go up 1, 2, 3, and go down 1, 2, 3. Now, if this were an ellipse, we would put points here at the top and at the bottom, and you would draw that stretched out circle. But we're not going to do that here. Instead, we're going to use that as a bit of a boundary, and we're going to draw this little rectangle. So this rectangle, whoops, that is not lining up right. I like how my pen all of a sudden decides not to line up right. So this is going to form a kind of a boundary, and your asymptotes are going to be those lines that cross through these diagonals like this. So that when we draw the hyperbola, it almost looks like you're doing parabolas off to the side. So you start to curve out and you start to get closer and closer to that asymptote. So we're going to do that over here as well. And then we copy that here on the left. So your hyperbola is not going to cross those asymptotes. It's just going to keep getting closer and closer to that as you go out to the edges. So with this graph firmly in place here, let's talk about what your domain and your range are. So you see that the domain is not all real numbers. We have a bit of a break there in the middle. So the domain is going to be coming from negative infinity up to this value of x right here, which is negative 7. We're including that, so bracket. And then union, we pick back up again when x is 7, and we go out to the right. And then our range, you can clearly see, I hope you can, that the range is going to be all real numbers. Even though it's opening out to the sides, we can see this guy's going all the way up, he's going all the way down, so the range will be all real numbers. All right, so make sure you take time to learn the terminology, your asymptotes, vertices, foci, transverse axis, conjugate axis, domain, and range. That way, whenever these words are spoken, you know exactly what's going on. Draw a picture. It doesn't have to be pretty. It's all about getting an idea about where the hyperbola is, its orientation, if it's opening to the sides, or if it's opening up and down, getting your asymptotes, finding all of your key things. So take your time. You got this.